students, let us continue our journey with the module 19 of unit 2. And today we are going to talk about the Stolper-Samuelson theorem. We started our journey with the Heckscher-Ohlin model. The Heckscher-Ohlin model discussed how the countries will engage in trade due to difference in factor endowment. Now, it said that a country which is abundant in a particular factor will export that good which it uses the abundant factor intensively, and will import the good which it uses the scarce factor intensively. One of the important outcomes of the Heckscher-Ohlin model was the factor price equalization theorem, which indicated that trade will lead to an equalization of relative factor prices between both the countries. Now, what will be the impact of this on the income distribution of the factor of production of the country? This will be an important discussion for today. Mind you, when trade begins, both the countries who were facing different price ratios at autarky now face almost similar price ratio as trade opens. For one country, the relative price ratio goes up. For other country, the relative price ratio goes down, and we have an international price ratios which is an average of these two price ratios. We have also learned that there is one-to-one correspondence between the commodity price and the factor prices, and we have understood that factor price equalization occurs with beginning of trade. Stolper and Samuelson went a step ahead to analyze what will be the impact of the changes of this relative prices of commodities on the income distribution pattern of the factor. And for that, they developed the Stolper-Samuelson theorem. The Stolper-Samuelson theorem points out that with commencement of free international trade, the benefit of the relative abundant factor whose price goes up and the scarce factor whose price goes down in relative term will suffer. The Stolper-Samuelson theorem is thus put as follows. If you look, an increase in the relative price of the commodity raises, in terms of both the commodities, the real reward of the factor which is used intensively in production of that commodity, and it reduces, in terms of both the commodities, the real reward of the other factor. For instance, suppose there is a rise in the relative price of good X, and mind you, we have assumed good X to be a labor abundant good which uses labor intensively. The rise in price of that good is supposed to increase the real wage return in terms of both good X and Y, whereas the real return of capital in terms of both the goods is supposed to fall. It demonstrates how the changes in the output process affects the price of the factors. When there is a positive production and zero profit is maintained in each industries. Thus, the whole purpose of learning Stolper-Samuelson theorem is to understand the effect on the factor income when the countries move from autarky to free trade. Also, this can help us analyze what will be the impact if there is an imposition of tariff. A tariff is a tax on import which basically raises the domestic price of the commodity. The assumption of the model is similar to that of the Heckscher-Ohlin model. We consider a two-country, two-commodity, two-factor framework where the production function is a linearly homogeneous following CRS. We have a perfect competition in both product and factor markets. There is a full employability of factors of production. We continue our assumptions of good X to be a relatively labor intensive, whereas good Y is a relative capital intensive good. The international terms of trade is fixed, and that domestic factor mobility within sector is permissible, whereas international factor mobility is not allowed, and that there is no impediment of trade in terms of any transport cost. Now we start to understand Stolper-Samuelson theorem with the help of initially a fixed coefficient type production function. As you can recall from the previous module, a fixed coefficient type production function is one where the unit coefficients of productions do not depend upon the factor price ratios. Now look at this. We have already assumed that there is a perfect competition that prevails in all the market, which implies that there will be no economic profit, which will be driven to zero, that is a normal profit condition. The normal or the zero profit condition will imply that the per unit cost of production will be equal to the price of the commodity. So for good X, we have Px is equal to WALX plus RAKX. For good Y, we have Py is equal to WALY plus RAKY. Px and Py are the prices of good X and Y respectively, whereas ALX, AKX, ALY and AKY, which are independent of WYR, are the unit factor coefficients for production of the goods. Let us assume that the prices are exogenously determined. As the firms are small ones in a perfect competitive framework, the prices are exogenously given. Since the factor ratio is fixed, in this model, W and R are the two unknowns. We will take the help of a diagram to understand the impact of change in prices on the relative factor prices. We consider this diagram below. In the wage rental plane, we plot the isocost line of the two commodities. For commodity Y, we have the black line, and for commodity X, we have this orangish line. Now, we observe that the set of all wages and rental rates which will generate zero profit in industry Y for price level Y is denoted by this flatter line. Whereas all sets of wage rental combination which will generate a zero profit condition for good X in the industry for price Px is denoted by this steeper line. Mind you, this is because good X is a labor intensive good and good Y is a capital intensive good. Point E, where both the curve intersect each other, indicates the point where there is a simultaneous zero profit condition maintained by both the commodity. This point represents equilibrium wage rental rate that would arise in the Heckscher-Ohlin model when the price of good Y is Py and the price of good X is Px. Now suppose there is an increase in the price of one good. In our case, let us take the price of good Y rises. So the price of good Y rises from Py to Py prime. Now as soon as the price rises, the impact will be from autarky to free trade or due to imposition of tariff which is imposed on import of good Y. The first impact will be the zero profit line will parallelly shift rightward. This is denoted by the rightward black line in the diagram. Our equilibrium point where both the zero profit line intersects move from point E to point F. If you observe, this results in a rise in rental rate and a fall in wage rate. If you look at point E, we had higher wage and lower rental rate. And at point F, we have now lower wage and a higher rental rate. Only at a high rental rate and a lower wage rate can a zero profit situation be maintained in both the industries now. Now if we use the slope of the zero profit line, that is ALX by AKX and ALY by AKY, we find that good X is a labor intensive good and good Y is a capital intensive good. When price of good Y rises, remember in this example Y is a capital intensive good. When the price of good Y has risen, the payment of the factor which is used intensively in production of good Y, remember good Y is a capital intensive good. As a result, the return of capital denoted by rental rate rises, whereas payment of the other factor, that is labor, which is not used intensively in production of good Y, falls. And this is the crux of the Stolper-Samuelson theorem, that an increase in the price of good will cause an increase in the return of the factor which is used intensively in the industry and will decrease the return of the other factor which is not used intensively. Now, if you have to explain this logically, let's take an example from good X of country 1. Country 1, when trade opens, starts exporting good X. And why so? Because in comparison to Turkey, as trade open, country 1 now faces higher relative price of good X in the international market. So the price of good X for country 1 rises. Now, as the price of good 1 rises, the country 1 will be interested in producing more of good X. The factors of productions will be made to shift from the production of good Y to production of good X. Remember, good X is a relatively labor intensive good. So it demands more labor. To produce good X, more amount of good Y is sacrificed. But as good Y is a capital intensive good, the bundle of factor released by good Y industry is more capital intensive than labor, whereas the requirement of factor of good X is more labor, less of capital. So this scarcity of labor that is now generated in the market due to demand of good X and the shift in production from good Y to good X leads to a rise in the price of labor in the market. However, the capital which has been released from good Y is now more than what is required in production of good X. So there is an abundance of good capital in the market which will depress the return of capital. So we can see here how with the opening of trade, when the price of the export good rises, this leads to rise in the return of the factor which was intensively used in the production of the export commodity and depresses the return of the factor which was not used intensively in the production of the good. And this is the crux of the Stolper-Samuelson theorem. explain the Stolper-Samuelson theorem mathematically. Now, to understand this, we will have to have, as Px increases, we will have to show P hat is greater than 0 and W hat is greater than Px hat and R hat is negative. I'll explain this as we move along. The zero profit condition, as we started, is as follows. Px is equal to WALX plus RAKX. This is the zero profit condition for production of good X. Whereas Py is equal to WALY plus RAKY is the zero profit condition for production of good Y. Now let us consider a variable coefficient technology. By variable coefficient technology we mean that ALX, AKX, ALY and AKY are now themselves a function of W by R. Let us consider equation 1. We are differentiating the first zero profit condition totally. So we find equation 1 prime after differentiating equation 1 using UV method for WALX plus RAKX. Now we can simplify this equation 1 prime by remembering the least cost factor combination for sector X. We remember MRTS LK is equal to minus W by R. MRTS LK is nothing but the slope of PPF. So we have dAkX by dALX is equal to minus W by R. This particular equation be written further as 1 double prime. Now if you put 1 double prime, that is W dALX plus R dAkX is equal to 0 in equation 1 prime, we will get dP is equal to this remaining part ALX dW plus AKX dr. Now we can do the similar thing for equation 2, that is the second zero profit condition. Py is equal to WALY plus RAKY, and differentiating we get a similar equation that has 1 prime. By similar treatment of the least cost factor combination like in good X, we can have that for good Y, and we can get from equation 2 prime dPy is equal to ALY dW plus AKY dr. Now we need Px hat, Py hat, W hat and R hat. For those students who are not familiar with hat calculus, it is nothing but a process to find the rate of change in a particular variable. So Px hat basically means dPx by Px. So change in Px with respect to Px. Py hat will be dPy by Py. So absolute change is dividing the relative change. W hat is equal to dW by W and R hat is equal to dr by R. Now remember, we found from equation 1a dPx is equal to ALX dW plus AKX dr. Now what we can do is, we can divide both sides of equation with Px. And with little manipulation, we can get the following equation. So if you observe here, I have divided both sides with Px. From the first component of the right side, I have multiplied with W and I have divided by W. And the second component of right side, I have multiplied with R and I have divided by R. Now, we can define this WALX by Px as the share of labor in the total cost of production of X. Mind you, W is wage rate and ALX is per unit requirement of labor. So total cost of labor is WALX and WALX by Px is the total cost of production of X's share in total production. Similarly, theta kx is nothing but wakx by px, which represents the relative share of capital in the total cost of production of x. Interestingly, if you observe, theta lx plus theta kx is equal to walx by px plus rakx by px. This is basically is equal to 1. Why? Because walx plus rakx from zero profit condition is equal to px. So what we find that this px hat, that is dpx by px, is equal to theta lx into w hat plus theta kx into r hat. Thus, px hat is a weighted average of w hat and r hat. In this case, from equation C, we can have two possibilities. As px hat is a weighted average of these two, we will have two possibility cases. One, where w hat is greater than px hat, greater than r hat, or w hat lower than px hat, lower than r hat. Similarly, from equation 2 we can derive py is equal to theta ly w hat plus theta ky r hat. And from here too, we can have two conclusions. That is, either w hat is greater than py hat, greater than r hat, or w hat less than py hat, less than r hat. Now, we can write px hat minus py hat by subtracting equation 1c and equation 2c. We get theta lx minus theta ly w hat plus theta kx plus theta ky r hat. Remember, theta lx plus theta kx is equal to 1. So theta kx is equal to 1 minus theta lx. Similarly, theta ky is equal to 1 minus theta ly. We can put in place of theta kx 1 minus theta lx and in place of theta ky 1 minus theta ly. So we will get px hat minus py hat is equal to theta lx minus theta ly w hat plus 1 minus theta lx minus 1 plus theta ly r hat, which can be simplified into px hat minus py hat is equal to theta lx minus theta ly is equal into w hat minus r hat. Remember, theta lx is nothing but factor intensity of good x and theta ly is nothing but factor intensity of good y. And in our example, good x was a relatively labor abundant good, whereas good y is relatively capital abundant good. That is, ALX by ALY was greater than ALX by ALY in capital intensive good too. So, theta LX is greater than theta LY. We have already assumed price of good X has gone up. So, PX hat minus PY hat is positive. Theta LX minus theta LY is positive. Therefore, to maintain the equation, W hat minus R hat must be positive. So, to keep this positive, W hat must be greater than R hat. From this we can write W hat is greater than Px hat greater than R hat. But we also remember Py hat has not changed. Py hat is equal to 0, but R hat has fallen. So combining this, we can say that R hat is negative. So we can mathematically justify the Stolper-Samuelson theorem, where the rise in price of good X leads to a more than rise in the return of the factor intensively used in the production of good X, whereas the return of the factor which is not used intensively in production of that good falls. And hence the Stolper-Samuelson theorem. Thank you, dear students.